Hi, my name is Shivam Dangwal and welcome to Physics for Cause. In this particular presentation, I will be going to explain you about the elements of modern physics. In this particular presentation, you will learn what were the reasons that the classical physics got failed and a new branch of physics called quantum mechanics got involved. How the quantum mechanics was evolved, you will be going to understand in this particular presentation. So let's begin with the introduction to quantum mechanics. So as we all know that what actually is physics? Physics is a branch of science which deals with the study of nature. Basically, we learn about the physical aspects of the nature in physics. So up to year 1900, physics is called the classical physics, which consists of mainly three parts. Number one is about the classical mechanics, second is about the thermodynamics, and the third one is about the electromagnetism. But actually, these three branches are classical physics were successfully able to explain any physical phenomena. But later on, the researchers and scientists noticed that some phenomena are not explained by the rules of classical mechanics. कुछ साइंटिस्ट्स एंड कुछ रिसर्चर्स ने नोटिस किया कि कुछ फेनोमेनन्स हैं जो कि क्लासिकल मैकेनिक के रूल्स के द्वारा एक्सप्लेन नहीं हो पा रहे हैं. मेनली देयर वर द टू डोमेन्स, ऐसे टू एरियाज थे जहां पर क्लासिकल मैकेनिक्स फेल्ड हो रही थी. नंबर वन इज अबाउट जब किसी ऑब्जेक्ट की वेलोसिटी बहुत ज़्यादा हाई कर दें अप टू 10 to the power 8 मीटर पर सेकेंड, एंड वी ऑल नो दैट द स्पीड ऑफ लाइट इज नियरली अबाउट 3 into 10 raised to the power 8 मीटर पर सेकेंड. सो अगर किसी ऑब्जेक्ट की वेलोसिटी स्पीड ऑफ लाइट के वेलोसिटी के नियर अबाउट हो जाती है, देन क्लासिकल मैकेनिक्स और वी कैन से दैट क्लासिकल फिजिक्स गॉट फेल्ड. सेकेंड वन इज अबाउट द एटॉमिक रियाम और द एटॉमिक डोमेन्स. अगर हम एटम के डोमेन्स के बारे में बात करते हैं, देन वी विल फाउंड दैट द क्वांटम मैकेनिक्स और अच्छे तरीके से एक्सप्लेन कर पाया, बट द क्लासिकल मैकेनिक्स, the rules of the classical mechanics were not able to explain about the atomic realm और atomic domains. इन दो रीजंस की वजह से हमको नई ब्रांचेस लॉन्च करनी पड़ी. सो टू एक्सप्लेन, जब कोई वेलोसिटी ऑफ ऑब्जेक्ट इज वेरी हाई, आई हैव ऑलरेडी टोल्ड यू अबाउट दैट इट वाज नियरली अबाउट 10 raised to the power 8 meter per second, a new branch of physics was introduced and the branch name is the theory of relativity. And when to explain about the concepts of atomic realm or atomic domains, a new branch of physics called the quantum mechanics got involved. So to explain these two phenomena, the two new branches of the physics got involved. So this is how the birthday of quantum mechanics is summarized in the next slide. So next we are going to talk about the birth of quantum mechanics. Basically, this is the date, and this date is very remarkable, 14th December 1900. Why? Because on this date, Max Planck, the picture you are seeing right on your screen is the picture of a famous physicist known as a Max Planck, who produced a paper to explain about the black body radiation. His paper was about to explain about the black body radiation. On the left side of your presentation, you are seeing his published paper on the topic of black body radiation. So, what he described? Classical mechanics was not able to explain the black body radiation. Max Planck derived the relation E is equal to h nu, where E is the energy of photon, h is the Planck's constant, and the value of Planck's constant is 6.626 into 10 raised to the power minus 34 joule second. Here you can see his work on the right hand side of the presentation, where he is doing the calculations for the Planck constant, and nu here is about the frequency. So this was the revolutionary relation derived by the Max Planck in this presentation. Okay, so this relation E is equal to h nu is the first sign of quantum mechanics, and this is the introduction to quantum mechanics, which gave birth to the new branch of physics known as quantum mechanics. So Planck stated that the radiation exists in a particle state and it has its own energy and packet of energy called quantum. Okay, but later on in 1905, Albert Einstein explained the photoelectric effect. The right side on the presentation, you are seeing the picture of a famous physicist Albert Einstein. He explained the photoelectric effect by applying the Max Planck theory of relation. Basically, this was the relation E is equal to h nu. Then the Albert Einstein used this relation laid by the Max Planck to derive and to explain about the photoelectric effect in his research paper published in 1905. Later in 1913, famous physicist Niels Bohr, the right hand side of the presentation, you are seeing the picture of Niels Bohr, who gave Bohr's atomic model, a famous model, Bohr's atomic model. So before 1913, Rutherford's atomic model was considered true. And what exactly was Rutherford's atomic model, we will be going to understand in the upcoming lectures. But Rutherford's atomic model was about the alpha particle scattering experiment, and he did with the gold foil. Okay, so Niels Bohr gave the Bohr's atomic model by introducing quantum conditions on the angular momentum. This was his actual paper where he talked about the Bohr's atomic model. Later in 1923, A.H. Compton, Arthur Holly Compton, scattered the X-rays with electron and introduced the Compton X-ray experiment. And this is one of the famous experiment which comes under the segment of elements of modern physics. So in classical mechanics, X-ray was considered an electromagnetic wave. क्लासिकल फिजिक्स के अंडर हम पढ़ रहे थे कि एक्सरे जो है इलेक्ट्रोमैग्नेटिक वेव है, बट आफ्टर द कॉम्पटन एक्सरे एक्सपेरिमेंट ही प्रूव्ड दैट एक्सरे इज अ पार्टिकल, बट by using the quantum conditions. He used the quantum conditions. Okay, so this was his actual research paper which he laid down, and we will be going to analyze and decode this research paper in the upcoming lectures by the topic of Compton scattering experiment. And this is the most famous and the most revolutionary experiment in the field of modern physics. The right hand side you are seeing the picture of A.H. Compton. Later in 1927, Davison-Zermer experiment. The two famous physicists, Davison and Zermer, they performed an experiment which shows that particles have wave character. And the observation are as follows. Here in the graph you can see that at 40 volt what will be the deviation, 44 volt, 48 volt, 54 volt. Basically this experiment was took under the concept of Nicol prism. And we will be going to understand this particular experiment in the upcoming lectures. Basically, we will be going to discuss all the concepts like photoelectric effect, Compton effect, Davison-Zermer experiment, and much more in the upcoming lectures. Okay, so this was the revolutionary which laid down the basis of why light can be considered as a particle or whether light can be considered as a wave. Because these experiments, black body radiation, photoelectric effect, and Compton effect shows that the radiations are the particles. But Davison-Zermer experiment said that the particles also have a wave character. And this is the most interesting part of the modern physics. I repeat that the experiments such as black body radiation, photoelectric effect, Compton effect, these all shows that the radiations are the particles in nature. But Davison and Zermer experiment said that the particles have a wave character. And this became a debate in the field of physics. ये क्या हो गया? एक debate बन गया in the field of physics. Thus, two researchers named as Heisenberg and Erwin Schrödinger developed two different theories. These two researchers, Heisenberg and Erwin Schrödinger, developed two new theories, but their objective was common. इन्होंने टू डिफरेंट थ्योरीज दी, बट इनका उद्देश्य यानी कि ऑब्जेक्टिव, कॉमन ऑब्जेक्टिव एम जो था वो कॉमन था. द थ्योरी ऑफ मैक्स प्लैंक Albert Einstein and Compton is considered as old quantum theory because ये इस जो इन्होंने रिसर्च करी है मैक्स प्लैंक ने, एल्बर्ट आइंस्टाइन ने, कॉम्पटन ने, ये ओल्ड हो चुकी थी, तो इन्होंने एक टर्म दिया ओल्ड क्वांटम थ्योरी के अंडर हम इसे इनकी थ्योरीज को स्टडी करते हैं. हाइजेनबर्ग डेवलप्ड अ न्यू थ्योरी फ्रॉम द ओल्ड क्वांटम थ्योरी. हाइजेनबर्ग ने कॉम्पटन इफेक्ट, ब्लैक बॉडी रेडिएशन एंड फोटो इलेक्ट्रिक इफेक्ट के थ्रू एक न्यू थ्योरी डेवलप करी एंड द नेम ऑफ द थ्योरी वाज मैट्रिक्स मैकेनिक्स. Basically, Heisenberg learnt various different concepts from Albert Einstein, from Arthur Holly Compton, and the Max Planck. So, the right hand side of the presentation, you are seeing the picture of Heisenberg, who developed a new theory from old quantum theory called matrix mechanics. Later on, Schrodinger developed a theory called wave mechanics. So, this is the picture of Schrodinger, Erwin Schrodinger. So, Heisenberg developed matrix mechanics and Schrodinger developed wave mechanics. But as I have already discussed, उनका objective was same. And collectively we called it as modern quantum mechanics. हम collectively क्या बोलते हैं उन्हें? Modern quantum mechanics. So, later on, some scientists like Dirac, Max Born and Pauli developed the new concepts. Here is the picture of Dirac, here is the picture of Max Born and Pauli. So this is how the modern quantum mechanics got evolved. But moving towards the quantum mechanics or the modern mechanics, we must know why the classical theory or the classical physics got failed. Classical physics क्यों fail हो गई? What were the reasons? So there were a set of reasons. First of all, the quantum physics was not able to explain phenomena related to atomic realm or the atomic domains. Second, it could not explain about the hydrogen spectra, which we will be going to cover in the upcoming lectures. The classical theory was not also able to explain the stability of atoms. This became a various concern in the field of quantum mechanics. The enormous range of conductivity of metals compared to insulators also could not be explained. Fifth one, the range of magnetic susceptibility is also very large. This was not also explained. Let me give you an example. The magnetic susceptibility for the iron is about 10,000. And the magnetic susceptibility for copper is about minus 0.001. Here you can see the large difference between the magnetic susceptibility of iron and copper. The classical physics was not able to explain why this difference is being created. इतना बड़ा difference क्यों आ रहा है? Classical theory was not able to explain. Classical theory also could not explain the emission of alpha particles from nucleus despite of the fact that it has insufficient energy. Classical mechanics could also not be explained about the concept of specific heat variation with temperature. It was not able to explain the variation of specific heat with relation to the temperature. The black body radiation, photoelectric effect, Raman effect, Compton effect were not successfully explained by the classical physics. That is how the new branch of physics called modern quantum mechanics was launched and was developed, I would say, because in the physics it is not a product to a launch. Modern quantum mechanics is the branch of now physics which we can say that it is a modern branch of physics which deals with the modern concepts like the atomic realm, like the photoelectric effect, like the Schrodinger wave equations, and like the special theory of relativity. So we will be going to cover these topics in details in the upcoming lectures. So thanks a lot for watching this particular video. make sure to hit the like button and hit the subscribe button for more amazing content. Thanks a lot for watching this particular video.